In this video, we're going to talk about an add-on in Grasshopper in Rhino. So I'm going to open Grasshopper from the button on the top bar. And specifically, we're going to talk about Kangaroo 2, which is an add-on within Grasshopper. So it's now part of Grasshopper, actually. So you can always find it, at least in the last version of Rhino, which is Rhino 8. And so what Kangaroo is about is basically creating simulations of many different kinds. So it's a physics simulation or physics simulator. And as usual, you have a lot of commands in this section. So we're not gonna see everything, but we're gonna see a couple of examples just to make you understand what you can do. And in architecture, for example, this can be used for tensile structure. So using like a tension that expand tissues. And so this is the main area right here. And here you find the solvers. Now the solver will run the simulation, and then you need to plug in or input some information in that. So usually you will start with one of these main solver here. And so I'm gonna put a basic solver, and then you have also like bouncy solver, etc., etc. They will just simulate things in a different way. And for what we're gonna do, we can use the basic or the bouncy solver. And so you have here different options for more specific situation. Otherwise, you can use the basic if you have a basic simulation. So first thing, you want to make sure that that's on, but if you want to control that, which is usually on by default, but maybe sometimes you want to like stop the simulation for some reason. So if you want to do that, you can add a Boolean toggle and you can switch from true to false. So this is going to be like a turn on and turn off feature like this. And of course, if you're interested in more, we have a Grasshopper video course, Rhino video courses in the channel, so you can check them out. If you are having problems with basic things in Grasshopper, for example. And also I'm going to add a button here to the reset. So every time I want to reset the simulation for some reason, I can do that. And these are the simplest ones. Not really mandatory, but they can be helpful. And then I'm going to drop in a mesh because this is going to be the output, the final output that we can then like bake in Rhino, and we can continue our work on and on. Now, the main one here is the goal objects at the top. So that's where you're going to plug basically everything in. And so what you need is to define, well, for our example, we need some tissue. So, and for that, we need to use a mesh. So when you drop in the mesh plane from the mesh ribbon in Grasshopper, it's going to create this standard mesh, which you can use. But if you want, you can also define a boundary. So if you want to increase the size or change there the proportions. And also I'm going to put an input slider so I can manage the width and the height counts. So to increase the number of faces. So let me go here like from 1 to, we can do 20, we can do 40. Now, the more you increase the number of subdivisions, the number of faces or number of poly, well, that is going to increase also the quality of the simulation, also the heaviness. So it's going to be heavier if you increase the number of subdivisions because it's going to take care of more phases essentially. Okay, so we can slide this. I input that in both width and height, so I maintain the proportions. And now this mesh goes into the goal object. So that's the first thing we need. And that's not enough. As you can see, that turns red because that's not enough. Also, we want to add a show node. So that's going to make what we're doing visible. So this mesh now will be visualized into the solver, let's say like this. Okay, and this is the first result, which is pretty boring. It's just let's say a flat tissue placed on a plane. and that's all. So how do we make this more interesting? We need to apply more actors to the play. So this one here is edge length, and is gonna, if I plug this in, is going to start to work. If I reset the simulation, is nothing is happening really, but we need to work a little bit with the length factor. So it's gonna add some physics already. So I'm gonna put the slider again, and here I'm gonna plug this in here, and you can see something's happening. Some forces have come into play. So, and kind of a randomic, you know, mm, scattering of points in there. So it's like a tissue or a plastic bag in the wind or something. So next, I'm also gonna plug the strength, so you can work a little bit with every like force. Okay, so every time I click on the button, it's gonna run the simulation again. So I can adjust some parameters and then run the simulation again and again and again. So that's the how everything works so far. And so what I'm gonna do now is add something more interesting. So to have a tensile structure, we need some anchors, like if we are building a tent. So with the anchors, with the mesh, I can define the anchors from here. So this other panel here in the mesh, so I can use, for example, mesh corner, which is going to analyze the object and it's going to extract the four corners there. Now you cannot see the mesh because I've hidden the mesh, so you can show and hide here by pressing the scroll wheel of the mouse, and I want to hide the initial mesh. I just want to see the corners there. So those will be the first corners. So if I plug this in, I hold Shift key to add another plug to the inputs. And now you can see that something is happening. So the force is like pulling in the middle, but the anchors are maintaining, those points stable. So everything else is moving, is reacting to the simulation. So let me try here with changing the strength, because I don't see. Yeah, there's something happening there. It's not really visible, but just make sure you play with all the parameters. And these are the four anchors that put the tensile structure to the ground, fix the texture to the ground. And now what we can do here is analyze the naked vertices. Now if I put this down here, and again I input the mesh, and here I can use the points to analyze what I am selecting. So these are the closest points, and then you have naked points which are on the edges. So depending on what you want to use, let's say I want to use the points that are in the middle here, and or again you can switch anytime. And I want to create anchors. So okay, if I do this, nothing really happens, because if I use the edges, everything will be like fixed in the middle. And so we need to put some or anchors in another position to see something. So let me just delete this. And let's say I want to use the closest points this time. And I want to look for the closest point here. So this gets this cloud of points, and it will use them to be deformed by other points. So to define the points that we're going to use as anchors, I'm going to search for the point node, and I'm going to put it here, and I'm going to input in the closest point node. And here I right click with the mouse and go set multiple points. This is where you define the other anchors, the other static points of the simulation. And from this node, closest point, into the anchor. So I put these closest points into the point, and I'm gonna use the points as targets. So this is how everything should be linked. It's a kind of complex thing, but this is how everything is gonna work. And if I click on the points, I can now put these points up, and you can see how they are reacting to the overall simulation. So it's a real-time simulation of this tensile structure. So depending on how many points I put there and how I position them is going to create automatically the tissue. So if I want, I can also add more points. So let's add one more point. I'm going to put it here in the top. And you can see it's not working until I hold shift click and add it to the target. You can see now it's only using that point right now, and we having something a little bit different. Now let's use also the other. So hold shift and add this to the targets and to the points. Okay, now I will be able to manage this set of points like differently. So I can put this down and creating something well different. So now you have infinite possibilities to create your textile structure. You can put the points anywhere you want. If you have like some structure down there, you can create the structure before and use the points, or you can use the structure later. So let's say I want to create the structure now with the grasshopper. I'm gonna go here to mesh and search for the mesh closest points, and I get the original mesh, the initial mesh, as a reference. So I'm gonna put the mesh there, and those points that if I use these 4 points, well, let's put it in. We need to go here, output and input here. So you can see that now these points will be projected down at the bottom in the original surface. Okay, I can take only those and create like some pillars, some columns. So let me create lines here. So the start point will be those, or the end point, it is the same. So we have an end and a start for those lines. So they create some poles. And now if I want to have like an actual solid, an actual structure, I just need like to create a pipe, and that's going to be fine. So let me create another line here. I want to do something else. So I want to use these two as start point, end points. So they create this kind of oblique lines. Okay, and let's say that that's the structure that is holding everything up. So now I want to plug in the pipe node, so everything becomes a structure. Of course, it's too big, so I need to decrease the radius. I'm gonna take a slider to manage the radius. I'm gonna put the radius in there and plug it in the radius. So I'm gonna drop down this, and you can see again I created some really basic structure, but as long as you create points and lines in Grasshopper, you can create any type of structure, and then you can use those lines, those points to also in the Kangaroo 2 simulation. Okay, so I'm gonna hide now some lines. Actually, I want to use only those ones. I like this solution better. So we are outputting a mesh from this, which is giving us kind of an issue, but well, it's working. So this is the final mesh. So we can now bake this, or we can also smooth more. If you use sub-D from mesh, we can make it even smoother. But I don't know. It's up to you what you want to use. And of course, if again I change the number slider at the beginning, this changes the number of phases, so we have more and more defined simulation, and also is like restarting every time I change the value. But if it doesn't, you can just reset the simulation, and again, once it's ready, you can bake. Once you're happy with that, you can bake the structure, you can bake the so let's bake this. For example, right click, bake into one layer, and then also I'm gonna do it with the tensile structure, right click, bake into another layer. So I have 2 different layers, so I can work with 2 different materials directly in Rhino. And I can continue in Rhino to do more, like defining the structure or the materials etc., etc. So that's all plain white at the moment, but I think that's good enough. By the way, I use the bouncy solver at the end, but you can use the solver, the simple solver as well. So you just need to plug in, the same values into the same points. And this will be all for this video guide. I hope you appreciated it. If you liked it, you can join the channel to stay updated for more. If you want, you can support the channel by joining the channel. This will help us creating more videos in Rhino, Grasshopper, Kangaroo. You can type in the comments also some requests. Maybe we will be able to satisfy them. So thanks for watching. See you in the next.